Hey there, it's Professor Daresh, and this is the third and final part of a three-part video series on greatest common factoring and the technique called factor by grouping. In this video, we're going to go over the technique called factor by grouping. Now, typically when we look at polynomials, they have a monomial in common. However, when we want to factor trinomials and polynomials, it is possible to have the GCF be a binomial. And this tool is really helpful when we need to factor complex expressions. So to show you a binomial in common, it looks like this: 3y times y plus 7 minus 4 times y plus 7. This is what our goal. This is what we want to happen when we're factoring trinomials and polynomials. So these have a common y plus 7. And if we bring the GCF out front, like we do when we're GCF factoring, we put y plus 7 in the front, and then we put whatever's left behind in the parentheses. Well, if you take out a y plus 7, the 3y is left behind, and the minus 4 is left behind. And again, we could just distribute this backwards, 3y times y plus 7 and minus 4 times y plus 7 to reproduce the same polynomial. Now, most polynomials that we're going to factor with factor by grouping are not going to be presented to us like this. Instead, they're going to be presented to us as a 4-term polynomial that we need to group. So let's take a look at multiple examples of how to do this. We'll do factor each polynomial, and this will be part A, 15x cubed minus 10x squared plus 6x minus 4. So right now, if you look at all 4 terms, they do not have anything in common across the board. 15 is divisible by 5 and 3. 10 is also divisible by 5, but 6 is not, and 4 is not. Since they don't have anything in common as a whole, we need to break them up into smaller chunks to see if we can factor. That's what grouping is. So the first thing we're going to do is we're going to group our polynomial into 2 pairs. 15x cubed is the first pair, and 6x is the second pair. Now, instead of looking at what all 4 pairs have in common, we're going to look at what each pair has in common with itself. 15 and 10 are both divisible by 5. They both have x, and the most x's I could take out would be x squared. If I take out this GCF, I'll be left with 3x minus 2. And again, I'm not showing all the scratch work I did when I was factoring GCFs, but I could, and it would help show this. So maybe in the next example, we'll do with full scratch work. Similarly, in the second one, I've got a 6 and a 4. 6 is divisible by 2 and 3. 4 is also divisible by 2, but is not divisible by 3. So the GCF here is 2. These terms do not have any x's in common because 4 does not have any x's. So if I divide each of these by 2, if I take out that 2, I'm going to get 3x minus 2. Now here's the moment of truth. If my factor by grouping works, if the expression is factorable, this should be a common factor. And I can write the common factor out front. 3x minus 2 times the 2 terms left behind. Especially in the beginning, if you're in doubt, multiply it back out to make sure that it does indeed give you the polynomial that you started with. We can summarize this GCF, or this factor by grouping, as a 3-step process. Step 1, group into pairs. Step 2, factor out the GCF from each group. And step 3, if the factors are in common, rewrite the factors like so. I feel like I could have worded that better, but if not, you can always try rearranging the terms and repeating the process to get that common factor. Let's take a look at one more example. If you need more than what's in this video, the PowerPoint does have a total of 4 examples. So this will be example 4, part B. And I'm going to show a lot more scratch work with this example just to give you an idea of what your scratch work could look like. So I've got 3x squared plus 4xy minus 3x minus 4y. Step 1 is to group into pairs. 3x squared plus 4xy. Be careful with subtraction. We kind of want to keep that in with the term, so I'm just going to put a little plus sign in between. Step 2 is to find the common factor from each set of pairs. So the common factor here, this can be rewritten as 3xx, and this can be rewritten as 2xy. They don't have much in common. Actually, it looks like they only have an x in common. So I'm going to put that x out in front, and then I'm going to multiply back together the leftovers. 3x plus 2 times 2y. Repeat with the second factors. Now I'm going to keep the negative. I'm only going to keep it on the front factor. The negative can be in common. If it's not in common, you do have to take it out. So we're going to do negative 3 times x for the first one. And then we're going to put a plus sign, negative 2 times 2 times y. So here, they both contain a negative. And if it helps, you can write it as negative 1 times 3 and negative 1 times 2 times 2. But we don't typically write the 1, so it's up to you. They don't have anything else in common. They just have a negative. So we're going to take out negative 1, and that's going to leave us with 3x plus 4y. This common factor worked because now I have a 3x plus 4y in common, and I know that my final answer is 3x plus 4y times the leftovers, x minus 1. So that concludes the video series on 2 factoring skills, greatest common factor and factor by grouping. We'll utilize these skills as we learn more factoring techniques and approach more complicated trinomials and polynomials that need to be factored.